Here are the answers to the section 5-7 homework, starting on page 176, the orals. We're asked to give the lowest common denominator and then rewrite the equation without any denominators. So looking at the denominators, we have a 4, a 3, and then this denominator is a 1. So we need the lowest common denominator for a 4 and a 3 and a 1. The smallest number that you can change 4 into by multiplying, and change 3 into by multiplying, and change 1 into by multiplying. That is a 12. 12 is the least common multiple of 4 and 3 and 1. Now we're asked to rewrite the equation without any denominators at all. The technique is to multiply all terms by the lowest common denominator. After all, that's why you would want to find that number to begin with. So let's times this by 12, times this by 12, and times this by 12. The reason for doing that is there will be some reducing. 4 and 12 reduce to a 3. 3 and 12 reduce to a 4. And then 1 and 12 don't really reduce. 5k times 3 is 15k. Then we have a minus sign. And then k times 4, that's 4k. And then there's an equal sign, and then 2 times 12. That's 24. Now we're not asked to go any farther and actually solve for k, but hopefully you notice how you would do that by combining like terms and then continuing on. Notice that by multiplying everything by the lowest common denominator, we no longer have any fractions, and we make our equation a lot simpler. Number 3 is the same. First we need the lowest common denominator for a 4, a 1, and a 6. That also happens to be a 12. So let's times the first term by 12, times this by 12, and times this by 12. 4 and 12 reduce to a 3. 1 and 12 don't reduce. 6 and 12 reduce to a 2. Notice how our denominators have all canceled away when we reduced. That's why we times everything by the LCD. X times 3 makes 3x. Then there's a minus sign. X times 12 makes 12x. Then there's a less than or equal to sign. And 1 times 2 makes 2. We have a new equation with no denominators at all, so it would be a lot easier to solve. Now in page 177 written, we're going to do that same technique, but then continue all over the way until we get answers. So we need to know the least common denominator if we have 3 and 4 and 2. That least common denominator, again, is 12. Because 3 times 4 is 12, 4 times 3 is 12, 2 times 6 is 12. You can change all of these into a 12. So times this by 12, times this by 12, times this by 12. Then cancel. 3 goes into 12 4 times. 4 goes into 12 3 times. 2 goes into 12 6 times. Notice that all of the denominators have canceled away. Let's rewrite our equation. X times 4 is 4x. X times 3 is positive 3x. And 7 times 6 is 42. Now let's continue on and actually solve for x. 4x plus 3x is 7x. Therefore, x equals 6. In number 3, we need to know what the common denominator is so that we can clear out the fractions. This is a 3, this is a 1, this is a 2. The least common denominator is the number 6. Because 3 times 2 is 6, 1 times 6 is 6, 2 times 3 is 6. Every one of those can be turned into 6 by multiplying by something. Let's times the first term by 6, times this by 6, times this by 6, and then do the reducing. 3 goes into 6 2 times. 1 and 6 don't really reduce, or if you want to think of it, it's like the 1 cancels away. And then 2 goes into 6 3 times. Let's rewrite. 2 times 2 times c is 4c. Then there's a plus sign. 1 times 6 is 6. Then there's an equals. 1 times c times 3 is 3c. Now let's solve this equation. We can subtract 3c from both sides. 4c take away 3c is 1c. And now there's a 0 on the right. Now we can subtract 6 from both sides. So we get c equals negative 6. Number 5, let's figure out the lowest common denominator for a 6 and a 4 and a 1. That would be the number 12 again. So we're going to times the first term by 12. Remember that you're including this in parentheses when you do that. We're going to times the middle term by 12. Don't forget parentheses around that so that they both get times by 12. And then over here, let's times by 12. Let's do some canceling. 6 into 12 twice. 4 into 12 3 times. And then 1 goes into 12 12 times. Now we can rewrite and we have no denominators. 2 times 3n is 6n. 2 times minus 2 is minus 4. Make sure you distribute this negative with the 3. Think of this subtraction as being a negative 3 that gets times to both of those. So negative 3 times 2n is negative 6n. Negative 3 times 5 is negative 15. And that's equal to 12. 6n minus 6n is nothing. There are no n's left over. Negative 4 and negative 15 makes negative 19. And on this side we have 12. Okay, this is a special case. The variable is gone and we end up with a false statement. That means there's no solution. You can write the word no solution or the empty set symbol. There are no numbers you could ever plug in for n and ever get this to work. Okay, number 7 is also an equation that has fractions as coefficients. It's just the fractions are in their decimal form. But this is the same as 500ths. This is the same as 700ths. Those denominators would be 100. We can clear these decimals by multiplying everything by the lowest common denominator of 100. So let's show that we want to times this by 100, and we want to times this by 100, and we want to times this by 100. What happens when you times the decimal 0.05 times 100 is you get a regular 5x. What happens here when you times 0.07 by 100 is you get a regular 7 that would then get times to what was in parentheses. And on the right side of the equals, 550 times 100 would be 550 with an extra 2 zeros on the end. This number is 55,000. Now let's solve this equation like we would back in chapter 1. First, the distributive property. We have the 5x at the beginning and then we're going to distribute the 7. 7 times 10,000 is 70,000. 7 times negative x is negative 7x. And that's equal to the 55,000. Now combine like terms. 5x minus 7x is negative 2x. Plus the 70,000 is equal to the 55,000. Let's continue on in the space up here by subtracting 70,000 from both sides. We get negative 2x equals 55,000 subtract 70,000 is negative 15,000. Now divide both sides by negative 2 to get x alone. We get 7,500. Number 9, let's solve this equation. This equation has fractions. We can clear the fractions by multiplying everything by the lowest common denominator. The denominator on the first term could be thought of as a 1. So the LCD, when you have a 1, a 6, and a 3, is a 6. So let's times this by 6, times that by 6, times that by 6. 1 goes into 6, 6 times. 6 and 6 cross out totally. And 3 goes into 6 twice. Let's rewrite our equation. We have a squared times 6. That makes 6a squared. Then there's a plus sign. We have 5a. Then there's an equal sign. And it looks like 2 times 2, which is 4. We've created an equation that no longer has fractions, but it's a quadratic equation. It goes to the second power. The technique that we've used in the past is to get a 0 on the right side. So let's subtract 4 from both sides. We have 6a squared plus 5a minus 4 equals 0. Now factor that trinomial. It will factor using FOIL. There are some possibilities to make 6a squared. Could be 3a and 2a, or it could be 6a and 1a. Let's try 3a and 2a and see if it works. There are different possibilities to make negative 4. It could be a 4 and a negative 1, could be negative 4 and positive 1, or it could be using some 2's. Let's try one of those possibilities. Let's put positive 4 in this spot and negative 1 in this spot. Here's why I did that. Because the outer product is negative 3a, and the inner product is positive 8a. And those add together and make 5a. And that's what the middle term was. So this is the correct factored form. The next step is where you take each one of those factors and set it equal to 0. So there's our first equation, and then here's our second equation. Now solve both of these. The first one creates the answer negative 4/3. The second one creates the answer positive 1/2. Number 19, this time we have a system of equations, and both of the equations in the system have fractions. So let's follow this technique about clearing the fractions. Let's rewrite the first equation without any fractions. We're going to times by the LCD. So what is the LCD of 2 and 3 and 1? It would be a 6. Let's times that by 6, times that by 6, and times that one by 6 and see what it makes. The 2 and the 6 reduce to a 3. The 3 and the 6 reduce to a 2. And then 1 goes into 6 times. So this makes 3x, then plus 2y, and then 12. Now in our second equation, our denominators 3 and 9 and 1. We're going to times by the least common denominator. So what is the least common denominator if we have 3 and 9 and 1? That would be a 9. So times this by 9, times this by 9, times this by 9. 3 goes into 9 3 times. 9 and 9 cancel away. And 1 goes into 9 9 times. So it looks like we have 1 times x times 3. That's 3x. Over here it looks like we have 1y. And on the right side, 1 times 9. Here's our new system. And this one has no fractions. So now let's decide whether to use combination or to use substitution. I'm going to choose combination. This is positive 3x. If the other one was negative 3x, then they would be opposites. So let's keep the first equation exactly the same as it is. And on the other one, let's times everything by negative 1. 3x times negative 1 is negative 3x. 1y times negative 1 is negative 1y. And 9 times negative 1 is negative 9. Now combine them. Notice how the x's cancel away. So we have 1y equals 3. We know the answer for y is 3. Let's substitute that into any of the equations that we have on the paper. We have a lot of them we could use. We have our original ones, but they have fractions, and plus I've scribbled things out and written all over it. They're really sloppy now. We have these equations that we had created with no fractions. Maybe one of those is a good one to substitute y equals 3. I'm going to put it right there for that y. It would become 3x plus 1 times 3 equals 9. This is 3x plus 3 equals 9. Now subtract 3 from both sides. We have 3x equals 6. Now divide by 3 on both sides. We get x equals 2. So our solution is 2, 3 in parentheses. Number 21 is very similar. We have a system of equations. Both of the equations have fractions. Let's clear those fractions by multiplying by the lowest common denominator. So what is the LCD of a 4 and a 6 and a 1? It would be 12. Let's times that by 12, times that by 12, times that by 12. 4 goes into 12 3 times. 6 goes into 12 2 times. 1 goes into 12 12 times. So we have x times 3, that's 3x, then a minus. Y times 2, that's 2y, then an equals. And 0 times 12 is still a 0. Let's transform the second equation. Our denominators are an 8 and a 12 and a 1. We need the least common multiple of 8 and 12 and 1. The smallest number that 8 can turn into by multiplying by something, and 12 and 1. How about 24? Let's times everything by 24. 8 goes into 24 3 times. 12 goes into 24 2 times. 1 goes into 24 24 times. So we have 3x times 3, that's 9x. Then a plus sign. 5y times 2, that's 10y. Then an equals. Negative 4 times 24, that's negative 96. Here's our new equation with no fractions. We can use substitution or combination. I'm going to use combination. This has a positive 10y. If this was negative 10y, it would be the opposite of the positive 10y. So let's turn that first equation into something with a negative 10y. We would need to times by 5. 3x times 5 is 15x. Negative 2y times 5 is negative 10y. And 0 times 5 is still 0. Let's keep this one the same. Now add the columns. 15x plus 9x is 24x. The y terms cancel away. And this is equal to negative 96. Divide by 24, we get x is negative 4. All right, we have the answer for x. Let's substitute it into any of the equations to get y. Again, I'm not going to use the original ones because they are all slopped up now. Plus, they had fractions. Who wants to use fractions? I'm going to put the negative 4 for that x right there. So this first equation becomes 3 times negative 4 minus 2y equals 0. This makes negative 12 minus 2y equals 0. Now add 12. We get negative 2y equals to 12. Now divide by negative 2. We get y equals negative 6. So in parentheses, negative 4, comma, negative 6. Number 27. We have an inequality instead of an equation, but solving it will use the same technique, and we're going to graph our answer on a number line. So this denominator is 4, this is 6, this is a 1, and this is a 1. The LCD would be the number 12. Let's times this first one by 12, times this by 12, times this by 12, times this by 12. 4 into 12, 3 times. 6 into 12, 2 times. And then 1 into 12 is 12, and 1 into 12 is still 12. Okay, let's rewrite this whole problem. 3 times n minus 2, using the distributive property, is 3n minus 6. Then a plus sign. N times 2 is 2n. Then a plus sign. 1 times 12 is 12. Then the inequality symbol. 0 times 12 is still 0. Now solve this. Looks like we can combine like terms on the left. 3n plus 2n is 5n. Negative 6 add 12 is positive 6. That's greater than or equal to 0. Now subtract 6 from both sides. So now we have greater than or equal to negative 6. Now divide by 5 on both sides. So we have negative 6 over 5. Here is our answer. Let's graph that. So on the line, find negative 6/5 anywhere you want. It gets a closed dot because of that or equal to bar, and then shade greater than, which is to the right. Number 29, let's solve that the same way. Whenever you have an equation or an inequality with fractions, the technique is to clear the fractions. And the way that's done is to multiply everything by the lowest common denominator. This is 12, this is 8, this one's 1. The LCD is 24. So you times by 24, don't forget parentheses around the binomial, times by 24, parentheses again, and then times by 24. 12 goes into 24 twice. 8 goes into 24 3 times. And 1 into 24 is still a 24 up here. Okay, let's rewrite this. 5 plus k multiplied by 2 with the distributive property is 10 plus 2k. Now we have a minus. We got to make sure that we distribute that minus with our 3. Think of that 3 as being a negative 3. So negative 3 times 3 is negative 9. And negative 3 times k is negative 3k. Then a less than, and then 24. It looks like we can combine like terms. 2k minus 3k is negative k. 10 minus 9 is plus 1. That's less than 24. Now subtract 1 from both sides. We now have 23. Now divide by negative 1 to get rid of that negative at the beginning. When you divide by a negative, the arrow switches. So here's our answer for k. We're asked to graph that. So here's negative 23. Open dot and graph everything greater than negative 23, which is to the right. Now for the review, we're going back to page 174. This is where we had complex fractions. Fractions that have other fractions within them. The technique on these involved multiplying everything by the LCD. So a very similar skill to what we were just doing with these equations. Some of these are just whole numbers, but you can always put a 1 under it to give it a numerator and denominator. The same down here. Let's multiply everything by the lowest common denominator. Our only denominators are a 1 and an n, so the LCD is 1n, or simply an n. Let's times everything by n. There, 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 and there. The reason for doing that is it clears the fractions. N over n cancels. N over n cancels. Let's rewrite this. N times n is n squared. 1 times n is positive n, and then negative 2. Under the big fraction line, n times n is n squared. 4 times n is positive 4n, and then positive 4. We might be able to do more reducing if we can get these in factored form. Let's try FOIL. N times n is the n squared. Positive 2 times negative 1 makes negative 2, and those two numbers add to a positive 1. In the denominator, this is a perfect square trinomial. It makes n plus 2 squared. So there is some reducing. This single n plus 2 will cancel away one of those n plus 2's, leaving one of them left over. So final result has n minus 1 in the top and n plus 2 in the bottom. Number 11 will also be a complex fraction after we rewrite it using this negative exponent. We can write that as 1 over y. And here's the plus 1, and down in the bottom we can write it as 1 over y. So now it's easier to see that it is a complex fraction. The lowest common denominator is a y. So times by y, times by y, times by y. These cross out, these cross out. So we're left with 1 plus y all over 1. That's just 1 plus y. Number 17, let's rewrite this and get rid of those negative exponents. So this is 1 over, and then this first part is 1 over a, and this part here could be written as 1 over b. Looking at our denominators, we have an a and a b. So our lowest common denominator needs to have both of those factors, ab. Let's times everything by ab. So times this by ab, times this by ab, and times this one by AB. The reason for doing that is the A's cross out, and now there's not a denominator under that 1. And over here, the B's cross out, and now there's not a denominator. So we have AB on the top, and in the bottom, B plus A. Number 29, this has a negative exponent as well, so let's first rewrite that. We have 1 plus, and then the part with a negative exponent we can write as 1 over a plus a to the negative 1. But we might as well fix that at the same time. So a to the negative 1 is 1 over a. This is a complex fraction. The only denominator we seem to have anywhere in the whole problem is an a. So let's multiply everything in this fraction by a. We can times by a, times by a, and times by a. So now we have 1 plus a over a squared plus 1. Because those a's cross out and we just have the 1 there. Now we have adding fractions and they don't have the same denominator. So let's make this first one have the same denominator as this one, which is a squared plus 1. To do that, we have to multiply top and bottom by the denominator we want. So times by a squared plus 1, and times this by a squared plus 1. We now have a squared plus 1 plus a, all over our common denominator. Let's rewrite the top and put things in standard form order. A squared plus a plus 1. That's all over a squared plus 1. That trinomial will not factor using FOIL, so I don't think that factoring will allow us to cancel anything out later. This is the best that we're going to be able to do for simple form. On page 172, we were adding and subtracting fractions. We didn't have complex fractions yet. We were only worried about having common denominators. In number 2, all the denominators are 20, so it's ready to add and subtract. 13 plus 39 is 52, and 52 subtract 77 is negative 25. And that's all over the denominator of 20. This does reduce. Top and bottom both divide by 5, so our final answer is negative 5/4. Number 6, we also have common denominators already. So add the tops together. 5 plus 3 makes 8, and that's all over our common denominator. Now this is even, this is even, this is even. We can divide everything by 2. So we get 4 over a plus 3. Number 8, we don't have common denominators. We need to decide what the lowest common denominator would be. It's going to be 6x. We can turn this into 6x by timesing by 2 and in the top. This one here is already 6x. So we can rewrite this as 4 times 2, which is 8, plus the 5, all over the common denominator of 6x. This makes 13 over 6x. Number 10, we don't have common denominators. So let's first figure out what it would be. It needs to have an a in it. And over here we see that we need to have b squared in it. We can turn this first one into ab squared if we times by a b and in the top. This one here we can turn into ab squared if we times by a and in the top. Let's rewrite this. We have 3b minus 4a all over our common denominator, which was ab squared. Number 14, again, adding and subtracting fractions, we have to have the same denominator. We have a 4 and a 2 and a 2x. So working with the numbers, we would need to have 4. But seeing that this one has an x, we also need an x in our denominator. We could turn this into 4x by timesing by x and in the top. We can turn this into 4x by timesing by 2x and in the top. We can turn this into 4x by timesing by 2 and in the top. So this makes 3x plus, this right here makes 2x squared minus, and this right here makes 10. And that's all over the common denominator of 4x. Let's rewrite this and put the top in the correct order. 2x squared plus 3x, then minus 10. And that's all over 4x. We could try factoring the trinomial, but we know that trinomials factor using FOIL, and that makes a binomial times a binomial. So that's not going to create something that reduces with 4 and x. So we might as well just leave it like this. Number 24, we need our lowest common denominator. This is 2x minus 1. This is 2x. The lowest common denominator would have both of those factors. It would have 2x times 2x minus 1. So we can turn this into that denominator if we times it by 2x and in the top. And we can turn this into the common denominator if we times it by 2x minus 1 and in the top. Let's rewrite. 4 times 2x is 8x. Think of this minus sign as being with the 3. So think of it as negative 3. Negative 3 times 2x is negative 6x. Negative 3 times negative 1 is positive 3. And that's all over our common denominator. Now let's combine like terms in the top. 8x subtract 6x is 2x. And then there's the plus 3. And that's all over our common denominator. And there is the final answer.